So the next one is quotient rule. Okay, so quotient rule. Quotient rule is similar to the product rule, but the product rule is all about multiplication and quotient rule is what? Division. So, and there is small changes with the what formula. And so with the quotient rule, the formula says your dy dx should be v du dx, just like the first one. But because it is division, we take minus u dv dx. Then here we divide it by v square. So that is the changes or the addition to the product rule. Okay, so we are going to solve a question under quotient rule. It's just the same. We are going to do the calculations just like the product rule. So we take one question and we look at how the quotient rule also works. And so one example we have, if y equals 2x plus 1, if y equals 2x plus 1 over x squared, find dy dx. So you see with the product rule, the two functions were multiplying, but under the quotient rule they are divided. So anytime you see two functions dividing, you need to introduce what, or you need to solve it or differentiate it using what, the quotient rule. But when the two functions are multiplying, that is when you use what, the product rule to differentiate them. And so this one we are going to differentiate them using what, the quotient rule. And just like the first one, the top one is u, the down one is what, v. Okay, so we know our formula to be dy dx. Oh, the formula is already here. So let's introduce our u is equal to what, 2x plus 1, and v is equal to what, x squared. Okay, let me clean them so that I don't get confused. So here we need what, du dx, we need dv dx. So we are going to differentiate them just like the first one. Du dx is equal to 2 and dv dx is equal to what, 2x. Okay, and we are going to substitute them into the formula. So we start with v, that is x. So we have x squared as our v, dy dx. So we have x squared as our v. Then multiply with du dx, which is 2. We have minus u is what, 2x plus 1. Multiplying what, dv dx, that is 2x, right? That is 2x. Then we divide everything by v square, and v is what, x squared. Yes, it's here. So we square it. Okay, so now we are going to expand the brackets. Dy dx is equal to, this will give you what, 2x squared minus 2x multiplying 2x will give you what, 4x squared. 2x times 1 will give you what, 2x. You need to bring this bracket because this negative is affecting this. So if you don't bring the bracket and you remove it just like this, you see the negative will affect only the 4x without and it will not affect the 2x. And in this case, you are going to get the answer what's wrong. So you just need to bring the bracket to indicate that the negative here is affecting this and that. So now let's expand it to get 2x squared minus 4, 2x squared minus 4x squared minus, because minus 2x, so that is our dy dx. So we can perform some calculations here. This minus this will give what, negative what, positive 2 minus negative 4 will give you negative 2x squared minus 2x. You can arrive here provided you have the answer in the options. But if you don't have the answer in the options, what you have to do is you factorize what, the common factors out. So dy dx is equal to, what's the common factor? We have 2 and we have x, right? So we have negative 2. So we can say negative 2x into brackets. Which number should we multiply by negative 2x in order to get this? That is x, right? So x. Then because this is negative, we need to introduce plus here so that when this negative multiplies this positive, it will give us what? The negative here, right? So we bring 1. So negative 2x times 1 here will give you negative 2x. Negative 2x times this x here will give you what's negative 2x. And you can say I am done. Okay, so that is how to go by when you see a question which is what? Two functions what dividing. You need to apply the quotient rule and you move on. Okay, so that is it. Let's move on to the next one. Let me give you one question to try under the quotient rule. Under the quotient rule. So try this and put it at the comment section. Y equals x cubed minus 2x plus 7 over no, it's too much. Let me give you x squared plus 4x over x. Okay, yeah, so do this one over x. Okay, and the quotient rule, solve it and give me the answer at the comment section. Now let's move on to the next one, and it's very simple. The next one is very simple. That is finding what? Higher derivatives. Finding higher what? Derivatives. Okay, so how do we find higher derivatives? That is rule number what? Is it 8? Higher derivatives. So higher derivatives, it means, everything that we have been doing is just finding the first differential. That is dy dy x. That is the first differential. And with higher derivative, it means after finding the first differential, you go on to find the second differential, the third differential, fourth, based on what the question is asking you to find, or what the question is demanding from you. So if the question is asking you to differentiate a given function to the third differential, it means you need to differentiate that particular function 3 times. You differentiate it first to get what? Dy dx. So the first one is first differential is equal to dy dx, and the second differential is equal to the square y over the x squared, right? Then your third differential is equal to the cube y over the x cube, like that. Okay, yes. And so let's pick a question, then we look at how to go by when you have been given a function to differentiate it to a certain differential. So this one, we have to find the third differential of this given function. That is x y equals x exponent 6 plus 4x squared minus 3 on x. We have to differentiate it to the third differential. The third differential. Okay. So how do we do it? We are going to differentiate it first. That is dy dx, right? So here, let's write our question. X exponent 6 4x minus 3 exponent of x. It is advisable that anytime you have a function and there is fraction in it, you change it to what? Linear. Do you get it? In order for you not to get what? Confused, because sometimes the negative can affect you. Sometimes the negative can affect you. So it is simple, very easier for you to change it to what? Linear. And this is how we do it. We are rewriting it again. We are not differentiating it. So x exponent 6 plus 4x. Now here, when this x comes up, it comes with exponent negative because it is inverse. And any inverse has exponent what? -1. Do you get it? And so we have -3 already. If this 3 comes, if this x comes up, it means the x will come here, but it will come with exponent -1. Do you get it? That is what? Inverse. Okay, so now since we have it in linear form, we can differentiate it. So we say dy dx. That is our first differential. So this 6 will come here. So we have 6. We reduce the exponent by 1. That is 5. plus 4x will give us what? 4 as usual. Then this negative 1 will multiply what? This negative to give you positive 3x. Then you reduce the exponent by 1. So it will be negative 1, negative 1. Right? Giving you what? Negative 2. So the exponent becomes negative 2. Have you seen the reason? This negative has changed to positive. If you continue to do it in a fraction form, you might forget that whilst you are differentiating it, you need to change the sign. So first differential, the sign will change. Second differential, the sign will change. Third differential, it will change. So provided you remember that, okay, but it is advisable you present it what? This way, linear form. So this is the first differential. The second differential is this one will multiply this to give you 30x exponent 4 plus, when you differentiate this, is 0. And when you differentiate this negative 2 will multiply the positive 3 here, right? And it will give you what? Negative 6. So negative 6x. Then you reduce the exponent by 1. So negative 2 minus 1 is negative 3. This is the second differential. Then you move on to the third differential. The cube y over d x cube is equal to 4 times 30 is what? 120 x. Then you reduce the exponent by 1 to get what? 3. Here negative 3 will multiply this negative 6 to give you positive what? 18. So you have positive 18x. Then you reduce it by 1 to get negative 4, because negative 3 negative 1 will give you negative 4. And so this is the final answer. You can leave it here. So this is the higher derivative we are talking about. Keep on differentiating it till you get to where the question is demanding or asking you to end. Okay, sorry, I've cleaned the topic. Okay, so okay, I will still give you a question for you to try this one. Y equals x exponent 5, let me say 2x exponent 5 plus 4x squared minus 7x. So you try this one for me. 7x. Okay, that is how my x is. So sometimes when you see the x, don't think it is u or n. You get it? Because I write fast, but x should be this. You get it? Yeah, so when you see it, sometimes just forgive me. That is how I write my x. Okay, so you try this one and you give me the answer. That is for higher derivative. Then the next rule is the chain rule. That is the chain rule. Okay, so let me clean this one. The chain rule. Chain rule. Chain rule also has a formula, and it also has two ways of solving it. So if you want to apply it in a theoretical form, you can go in for the formula, right? Then if you are tackling, let's say, an objective or let's say MCQ question, you can go by the short way. Do you get it? So with the chain rule, the formula is your dy dx should be equal to dy du multiplying du dx. So you don't need to memorize this. It's very simple. In every equation, your left hand side must be equal to your right hand side, right? So this left hand side has what? Dy dx. So it means the right hand side must also equal to dy dx. Why? When you cancel this du with this du, you are left with what? Dy dx. Do you get it? It's same as what you have here. So this one you don't need to memorize it, that there's the formula. Always have it in mind that the du must be here, what? That diagonal form. Do you get it? So that they can cancel themselves to give you the dy dx. That is all. Okay. And so that is what we are going to look at. Okay. So there's the chain rule. Du. This is the chain rule, and it's very simple. Let's pick a question. We introduce the chain rule, or this rule is used to differentiate a function whereby you have what? Higher exponents. Do you get it? Sometimes you are differentiating a function like x minus 2 exponent 2. This one has small, or the exponent is very what? Small. So you can just do it very quick. You square this one to give you what? X squared You square this one to give you what? Positive 4. Then you use this 2 to multiply through to give you what? 2x, sorry, 2 times x is 2x times negative 2 is minus 4. So minus 4x. You rewrite it as x squared minus 4x plus 4. So with this one, you can just solve it just like this. But sometimes if you have exponent 7, unless you introduce Pascal triangle and other forms of what? Binomial distribution before you can be able to what? Solve this. But in a situation whereby you are dealing with differentiation, do you get it? And you have been asked to differentiate. This one, they were specific that you are to what? Differentiate. So it means if it is theory, you need to apply what? The differentiation what? Method. And this one, you need to what? Introduce the chain rule. Okay, so let's say you have a function y equals 2x squared minus 3 exponent 7. You have something like this, and you have been asked to find dy dx. Okay, you need to first represent everything here by u. Okay, so we say u is equal to everything in the set. So 2x squared minus what? 3. So u has been represented by everything in this set. And so if u has been represented by everything in this set, then it means we can remove what is in the set and place u here to get y is equal to u exponent 7, right? Because we have placed u here. And so we have y equals u exponent 7, right? Okay, so this is u, this is y. Let's look at the formula. The formula say we are to get what? Dy du. How do you get dy du? You are to differentiate y with respect to u. And this is y, this is u. So you differentiate this function. This is the u dx. So it means you are to differentiate what? U with respect to x. So you differentiate this one to get the u dx. Then you substitute it in the formula. Then you are done, or you are good to go. So here we say the u dx because we are differentiating u with respect to x is equal to 4x, right? And here is 0. Okay, so here too we have dy du. We are differentiating y with respect to u. So dy du is equal to this 7 will come down here. So we have 7u exponent what? 6. Do you see that? Yes. Then we are going to insert this into the formula. Then we do our calculations. Okay. So let's see. Dy du, and we have dy du to be 7u6. So dy dx here is equal to dy du, which is 7u6. You write 7u6 multiplying du dx, and du dx is what? 4x. So multiplying 4x, that is what we have here. Okay, so now we can multiply this by this to get dy dx equals 7 times 4 is 28. So you have 28 x u 6. So you have this function. You are not done because the question that you were given, there was no what? U. You introduce what? The u. So in this case, you have to resubstitute. You have to bring back what? The function. Do you get it? You have to bring back the function. And so u was represented by what function? This is the function. So we are now coming to put the function here back. So dy dx is equal to 28x. Then when we get where the u is, we bring what? The function, which is 2x squared minus 3. Then we bring the exponent 6. So this is the differentiation. We are done. And this is how to use the chain rule. Very short and simple step to go through. Okay, you first introduce u here, then you write this function, you differentiate both of them, you set them in the formula, and you are good to go. Okay, so this is the way of going, or the way of solving what, or differentiating a function using what? Chain rule. So let's look at how to differentiate the same function using the shortcut or the simple step method without using the formula. Okay, so I don't want to clean the work, so I would like to use this space for the calculation. We have this question, right? And so this question, we say our dy dx is equal to, we are saying from the power rule, if this was a function, this, you just bring this 7 here, right? Then you reduce the number by 1 to get 6. That is from the power rule, right? Yes. So after doing that, just differentiate what is in the set or the bracket. That is it. And you are good to go. So here we bring the 7 here and we reduce the power by 1. So we see 7, then we bring 2x squared minus 3, and we reduce the exponents by 1. That is what? 6. This is from the power rule. But there is one thing to do again. That one thing is to differentiate this. If you differentiate this, you are multiplying it. So if you differentiate this, you get what? 4x, right? 4x. This is 0. So you see, you are done. You are done with the work. And this 4x can multiply what? This 7. So because the 4x is not or has no exponent here, so you can directly multiply it by the 7. So 7 multiplying 4x is giving you what? 28x. Then you bring your bracket again, 2x squared minus 3 into bracket 6. So that is the same answer you have here. The answer you have here using the formula is the same answer you have here using the shortcut method. So this is for MCQ, this is for MCQ, and this is for what? Theory. Okay, yeah. So it's very simple. It's very simple. Try this one. 2x minus 3 exponent 5. Let's apply the simple step, because for the formula you are okay with it, because we are done with the product rule, quotient rule, so you're okay. So with a simple one, we say dy dx is equal to, we bring the 5 here, then we say 2x minus 3, we reduce the power by 1 to get what? 4. So this is the power rule. Then when you finish, you differentiate what is in the brackets, then that is 2, this is 0. So you multiply this 2 by this 5, you get 10. So dy dx is equal to 10 2x minus 3 exponent 4. So that is it. This is the final answer using what? Chain rule. So just use this same formula to solve using what? The rule or the formula. You get it? When you finish, you put the answer in the comment section for me to check whether the answer is the same as what? This. Okay. Yeah. So that is it for the chain rule.